Have you ever stared at an exam question you were sure you knew the answer, but when you got it back, you'd lost marks? Well, today we're going to figure out exactly why that happens. We're taking a real GCSE chemistry exam question and tearing it down piece by piece to see exactly what an examiner is looking for to give you every single mark.
You know that feeling when you finish an answer and you think, was that it? Was that what they wanted? Well, the secret to cracking that code, to knowing exactly what the examiner wants to see, is hidden in plain sight. It's the mark scheme. It's basically the blueprint for a perfect answer, and today we're going to learn how to use it.
So for this explainer, we are diving into question 2 from the AQA June 2023 Higher Tier Chemistry paper. This question is a fantastic example of how exams test more than just your memory. They test your practical skills, your data skills, and your ability to think like a scientist. Let's get into it.
So, here's the setup. It's pretty straightforward. A student is dissolving ammonium nitrate, which is just a white crystalline solid, into some water. The key thing here is they're changing the mass of the chemical they add each time, and they're measuring what happens to the temperature of the water. Understanding this basic premise is step 1 to unlocking all the marks.
Okay, so here's the play-by-play of what the student did. They measure out some water, check the starting temperature, dump in a specific amount of the ammonium nitrate, give it a good stir, and then record the lowest temperature the water hits. Then, they just do it all over again with different amounts of the chemical. Got it? Good.
Right. Now that we're clear on the experiment, let's get to the actual questions. We're starting with the fundamentals, identifying the variables before we move on to the big one, plotting a graph. This is where a ton of marks can be won or lost, so let's make sure we nail it.
Okay, first question up is an absolute classic. They want you to name the independent and dependent variables. So take a quick second. What is the one thing the student is changing on purpose, and what is the thing they're measuring to see the effect?
And here are the answers pulled directly from the mark scheme. The independent variable, the thing you change, is the mass of ammonium nitrate. The dependent variable, the thing you measure, is the lowest temperature reached. See how specific that is? Just saying temperature might not be enough. The details matter.
All right, buckle up. Here comes a 3-mark question that's all about your practical skills, even though you're just sitting at a desk. You're given a table of results and an empty graph. Your job? To plot the data. Precision here is everything.
So, this is your canvas. A blank grid, axes all labeled for you. All you have to do is take the numbers from the table and turn them into points on this graph. Let's see what the mark scheme says about doing this perfectly.
Now this is important. The marks are broken down. You get a whopping 2 marks just for plotting the 6 points in the right place. But look at the tolerance. You've only got half a tiny square of wiggle room. That's it. If you get 4 or 5 points right, you only get 1 mark. So you got to be careful and accurate. And for that third and final mark, it's all about the line of best fit. Now, listen, this is not a game of connect the dots. You need a single straight line drawn with a ruler that shows the general trend. A good rule of thumb is to try and get an equal number of points above and below your line.
Okay, so you've drawn a beautiful, accurate graph. Awesome. But you're not done with it yet. The next step is always to use it. This is where you prove you can interpret your data and pull conclusions from the graph you've just created.
So the question asks for the initial temperature. But hang on, that value isn't in the data table. So how do you find it? Well, look closer. The question gives you a massive clue. It literally says you should extend your line of best fit. It's telling you exactly what to do. And the scientific term for this is extrapolation. Think about it. The initial temperature is the temperature before any chemical was added, right? That's when the mass of ammonium nitrate was 0. So to find it, you just take your ruler and extend your line backwards until it hits that y-axis.
And that's exactly how you get the mark. The examiner wants to see that you've correctly read the temperature value right where your extended line hits the y-axis. Once again, there's a tolerance of half a small square, so a neat, accurate line is really going to pay off here.
Okay, we are on the home stretch now. The final part of this question digs into some deeper scientific concepts: data analysis, experimental errors, and uncertainty. This is where they separate the good answers from the great ones.
Let's start with a nice, simple one-marker. Endothermic means a reaction takes in heat from its surroundings, making things colder. So how do our results show that? The mark scheme wants just 2 words: temperature decreased. That's it. Short, sweet, and to the point.
All right, now for a concept that sometimes trips people up,
uncertainty. The question points out that for one result, the mean temperature was written as 16.5 plus or minus 0.3 degrees Celsius. So what does that plus or minus thing actually mean?
Well, this is a great example of where the mark scheme gives you some options. You get the mark for explaining what that 0.3 represents. You could just say it's the uncertainty, or you could say it's the range about the mean. You could even show it with a little bit of math. Any of these will get you the mark.
And that leads us perfectly into our very last question. When you look at those repeat readings, you can see they're all slightly different. They're clustered around the average. So what kind of experimental error does that point to?
The answer is simply random error. That's it. These are the small, unpredictable fluctuations you get in any measurement. It's like throwing darts. Even if you're a pro, your darts will land in a smaller cluster around the bullseye, not in the exact same hole every time. That's random error.
And there we go. We have just gone through an entire 11-mark question, looking not just at the answers, but at how every single mark is awarded. So what's the big lesson here? What's the main takeaway from all of this?
It's this. The mark scheme is not a secret document just for teachers. It is your ultimate revision tool. It's the rule book for the exam, and if you want to win the game, you've got to learn the rules. It shows you the exact phrasing and the specific skills that score points.
We've cracked the code for one question today, but this exact same technique works for every single subject, on every single exam paper. So I'll leave you with this thought. What secrets are waiting for you, hidden inside your other mark schemes? Now you've got the toolkit to go find out. Thanks for joining me.